Look up at the night sky. For most of human history, those lights were just distant fires in the cosmic dark. But now, we know they are suns, each with the potential for planets. We've always dreamt of finding another Earth, a place to start a new chapter in our cosmic story. That dream, now, has a name. Proxima Centauri B. This is the closest exoplanet ever found, an exoplanet being a world orbiting a star other than our Sun. The very next star system over from ours has a planet roughly the size of Earth. Proxima B is a monumental leap in our quest to understand our place in the universe. It's our cosmic next-door neighbor. Before its discovery in 2016, the nearest known exoplanets were dozens of light-years away. Pure science fiction. But Proxima B is close enough that we can imagine sending probes to visit it. It transforms the dream of interstellar travel into a concrete goal. So, let's talk about this world. What it is, where it is, and why it matters. This is a story about science, but also about hope. It's about our desire to explore, to push boundaries, and to reach for the impossible. Proxima Centauri B is more than just a rock in space. It is a symbol of our future, a destination, the beginning of a new age of discovery, beyond the familiar shores of our solar system. The journey begins now. We stand at the threshold of the stars. Our next great adventure is just 4 light-years away. The universe has never felt closer, and Proxima B is our invitation to explore it. Let's take the first step. How do you find a planet you can't see? Proxima Centauri B is too small and dim to photograph directly. Astronomers had to look for its ghost, the effect it has on its star. This is the radial velocity, or wobble method. Imagine a star and planet locked in a gravitational dance. The planet's gravity tugs the star, causing it to wobble. Astronomers at the European Southern Observatory used the HARP spectrograph in Chile to watch for this tiny, rhythmic wobble. They collected data for years, measuring the star's light for subtle shifts. When the star wobbles toward us, its light shifts blue. When it wobbles away, it shifts red, the Doppler effect. In 2016, the signal became clear, a regular wobble every 11.2 days. The math revealed a planet at least 1.3 times Earth's mass. The ghost in the machine was real. A world had been found. The announcement electrified the world. We had found Earth's nearest cousin, hiding in plain sight. The search was over, and a new dream had just begun. Proxima B became the most exciting exoplanet discovery yet. It proved that even our closest stars can host planets. The universe suddenly felt a lot more crowded, and our place in it, a little less lonely. To find Proxima B, you need to know about its star, Proxima Centauri, a member of the Alpha Centauri triple star system. Alpha Centauri A and B are bright, sun-like stars, but Proxima Centauri is a faint red dwarf orbiting farther out. At just 424 light-years away, Proxima Centauri is our closest stellar neighbor. That's about 40 trillion kilometers, unimaginably far for us, but close on a cosmic scale. Proxima Centauri is tiny, only 1/8 the mass of our Sun, and shines with less than 1% of its brightness. You can't see it with the naked eye, but it's there, a faint red spark. Proxima B orbits this star incredibly closely, much closer than Mercury orbits our Sun. Its year lasts just over 11 Earth days. This proximity puts it in a unique position, close enough for warmth, but orbiting a cool, dim star. Its special location is the key to its scientific interest. Proxima B is a world huddled close to a tiny campfire in the vast dark. It's a focal point for our interstellar dreams. The nearest exoplanet is not just a distant idea, it's a real place, right next door. And it's waiting for us to explore. Why does Proxima B matter so much? It sits in the habitable zone, the region around a star where liquid water could exist. Where there's water, there could be life. Proxima B is Earth-sized, and in the habitable zone of the very next star system. It doesn't guarantee habitability, but it means it's possible. This discovery fuels our deepest instincts as explorers. Proxima B gives us a tangible destination, a real place, not just a point of light. It makes the dream of interstellar travel feel achievable. For dreamers, it's a canvas for imagination and hope. Could we build a new home there? Could humanity become multiplanetary? Proxima B represents a second chance, a backup for humanity. It's a symbol of hope, and a reminder that our future can be as vast as the universe itself. The stars are no longer out of reach. What do we know about Proxima B? Its minimum mass is about 1.17 times Earth's, suggesting it's a rocky terrestrial planet. Its 11.2-day orbit keeps it close to its star, warm enough for liquid water, but likely tidally locked. One side faces eternal day, the other eternal night. Life, if it exists, might survive in the twilight zone between. Proxima Centauri is a volatile red dwarf, unleashing powerful flares that could strip away a planet's atmosphere. Whether Proxima B has a protective magnetic field or thick atmosphere is still unknown. Despite these challenges, we know its size, orbit, and potential temperature. Future telescopes may reveal if it has an atmosphere, water, or even signs of life. For now, it remains a mysterious silhouette, a world of shadows and possibilities. Each new discovery brings us closer to understanding our neighbor. The next chapter is waiting to be written. The path to Proxima B is filled with colossal challenges. The distance, over 40 trillion kilometers, would take current spacecraft tens of thousands of years. We need a revolution in propulsion technology to even consider sending a probe. Interstellar space isn't empty. Tiny dust particles could destroy a fast-moving ship. Any interstellar craft would need powerful shielding and precise navigation. Proxima B itself is blasted by intense radiation from its star's flares. Human explorers or probes would need heavy protection, perhaps even underground habitats. Tidal locking creates extreme temperature differences and ferocious winds. Settlers would have to find water, extract resources, and grow food in an alien world. Every step is a monumental engineering and scientific challenge. The journey is hard, but making a home there is even harder. Yet these challenges are not insurmountable. They are invitations to innovate, to push the limits of what's possible. The dream of reaching Proxima B will drive new discoveries, and one day, it may take us to the stars. What if Proxima B isn't right for us? That's where terraforming comes in. Earth shaping a planet to make it habitable. First, we'd need to send probes to survey the planet. Atmosphere, temperature, water. Knowledge comes first. No blueprint, no renovation. If Proxima B is cold and dry, we might introduce greenhouse gases to warm it up. Factories could pump these gases, melting ice and forming rivers and oceans. Next, we'd seed the new waters with hardy microorganisms, algae and cyanobacteria to produce oxygen. Over thousands of years, they'd transform the air, making it breathable. Terraforming is a slow, patient process, nurturing a new biosphere into existence. It's the ultimate act of planetary engineering, and it starts with a single probe. Terraforming is a distant dream, so what are the first real steps? We need better telescopes to study Proxima B, direct imaging, atmospheric analysis. The next step, send a probe. Projects like Breakthrough Starshot aim to launch tiny nanocraft to Alpha Centauri at 20% the speed of light. These probes, packed with cameras and sensors, could reach Proxima B in just over 20 years. They'd snap pictures, gather data, and beam it back to Earth. This would be our first close-up look at another world. If the data is promising, larger robotic missions could follow. Only after decades of exploration could we plan for human footsteps. The journey of 1,000 light-years begins with a single photon, and every step brings us closer to the stars. Our fascination with Proxima Centauri B comes from deep within us, the spirit of curiosity. We look up and see destinations, not just lights. The universe is the ultimate puzzle, and we are born problem solvers. The challenges are immense, but the pursuit drives innovation and progress. Technologies for interstellar travel will help us here on Earth too. Proxima B may be a barren rock or a water world, or something stranger. The quest to find out is what matters. The journey will teach us about the universe, technology, and ourselves. It will inspire new generations and unite humanity in a common purpose. So, when you look up, remember Proxima Centauri B. Just 4 light-years away, a world not much different from ours circles its star. The cosmos is filled with possibilities. Our journey to the stars has already begun. Keep looking up. Imagine looking up at the night sky and seeing countless stars, each a distant sun. For thousands of years, humans have gazed upward, wondering what lies beyond those tiny points of light. Are we alone, or do other worlds circle those distant stars, waiting to be discovered? The closest star to our Sun is Proxima Centauri, a faint red dwarf just 4.2 light-years away. Though it's invisible to the naked eye, this small, cool star is part of the Alpha Centauri system, our nearest stellar neighbor in the vastness of space. In 2016, astronomers made a groundbreaking discovery, a planet orbiting this star, known as Proxima Centauri B. This was a moment that changed our understanding of the universe and our place within it. This exoplanet is the closest one ever found outside our solar system. It orbits just the right distance from its star to spark our curiosity about its potential for life. Its discovery made the idea of visiting another star system feel less like science fiction and more like a real possibility for future generations. Proxima B orbits within its star's habitable zone, the region where temperatures could allow liquid water to exist on its surface. This is a key ingredient for life as we know it. Where there's water, there's potential for life. The possibility that Proxima B could have oceans or lakes has fueled imaginations and scientific inquiry alike. Suddenly, Proxima B became a prime target for future observation. Telescopes around the world and in space are now focused on this tiny, distant world, searching for signs of an atmosphere or even the faintest hints of life. Could it be a second Earth? Could it harbor life, or is it a barren, rocky world? These questions drive astronomers to keep searching and learning. The excitement wasn't just about proximity, it was a milestone in our search for other worlds. For the first time, we had found a planet so close it felt almost within reach. For centuries, we could only study planets in our solar system, limited by the technology of our time and the vast distances between stars. Now, technology lets us detect planets orbiting other stars. With each new discovery, our understanding of the universe grows, and so does our sense of possibility. Proxima B is the poster child for this new era of discovery. It represents the hope and excitement of finding new worlds beyond our own. It reminds us the universe is filled with countless planets, each with its own story, its own mysteries, and perhaps its own forms of life. Its discovery marks the beginning of a new chapter in our exploration of the cosmos. We are no longer limited to our solar system. The stars themselves are becoming our next frontier. We're building better telescopes and dreaming bigger dreams. Each new instrument brings us closer to answering the age-old question, are we alone? Proxima B is not just a distant world, it's our closest exoplanetary neighbor, a tantalizing reminder that the universe is full of surprises. Its existence challenges us to ask, what else is out there? What other secrets does the universe hold waiting for us to uncover? And could we ever reach it? The journey to Proxima Centauri B may be long, but the adventure has already begun, inspiring a new generation of explorers to look to the stars and dream of what lies beyond. Scientists are cosmic detectives, piecing together the mysteries of the universe from faint signals and distant lights. Their work is a blend of curiosity, patience, and cutting-edge technology, as they sift through mountains of data in search of something extraordinary. They're searching for clues about our place in the universe, hoping to answer age-old questions about whether we are alone or if life might thrive elsewhere among the stars. The discovery of Proxima B, an Earth-sized planet, orbiting in the habitable zone of the nearest star to our Sun, was electrifying for the scientific community and the public alike. It sparked imaginations and renewed hope that another world like ours could exist so close by, in cosmic terms. Its mass suggests it's rocky, like Earth, making it a top candidate for hosting life as we know it. The possibility that it could have a solid surface, perhaps even water, makes it especially intriguing. Its proximity, just over 4 light-years away, means that with future technology, we could one day send robotic probes to study it up close, gathering data that telescopes simply can't provide. Ambitious projects like Breakthrough Starshot are already imagining such missions, designing tiny spacecraft that could travel at a fraction of the speed of light to reach Proxima B within a human lifetime. Most stars in our galaxy are red dwarfs like Proxima Centauri, so by studying Proxima B, we're not just learning about one planet, we're opening a window into a huge population of potentially habitable worlds orbiting these common stars. But are these worlds truly good places for life, or are they inherently hostile, battered by stellar flares and extreme conditions that make survival difficult? Proxima B is a key piece of the puzzle in our search for habitable worlds. helping us refine our understanding of what makes a planet truly suitable for life. It's a natural laboratory for testing our theories about life beyond Earth, and every discovery brings us one step closer to answering the ultimate question: are we alone in the universe? To truly understand Proxima B, we must first turn our gaze to its parent star, Proxima Centauri. This is not a star like our Sun, but a small, cool red dwarf glowing with a dim, steady light. Red dwarfs are the most common stars in our galaxy, yet their faintness makes them nearly invisible to the naked eye from Earth. Proxima Centauri, though our closest stellar neighbor, is just a tiny spark in the vast darkness, its energy output a fraction of what our Sun provides. Proxima B orbits incredibly close, just 7.5 million kilometers from its star, a distance that would place it well inside Mercury's orbit in our own solar system. Here, a year passes in only 11.2 Earth days, as the planet races around its sunlit companion. The surface of Proxima B is bathed in a deep red and infrared glow, creating a world of perpetual twilight. There are no blue skies here, only a dim, ruddy atmosphere, where the sun never rises high or shines with the brilliance we know on Earth. If life exists, any plants or photosynthetic organisms would need to evolve in remarkable ways, adapting to the faint red-tinged sunlight. Their leaves might be black or deep purple, maximizing every photon in this alien environment. Proxima B's position in the so-called habitable zone suggests that liquid water could be possible on its surface, yet the average temperatures might plunge as low as -40 degrees Celsius, making the search for warmth and stability a challenge for any potential life. The reality is likely even more extreme, with wild temperature swings between the planet's day and night sides. If Proxima B is tidally locked, one side could be scorched while the other remains frozen in darkness. Despite being just 4.2 light-years away, our closest exoplanet neighbor, Proxima B is still an astonishing 40 trillion kilometers from Earth, a distance that dwarfs anything in our solar system. With today's technology, even our fastest spacecraft would take tens of thousands of years to make the journey, making Proxima B feel both tantalizingly close and impossibly far. All our knowledge of this distant world comes from the faintest signals, tiny wobbles in starlight, subtle shifts in color, captured by our most sensitive telescopes. Piece by piece, astronomers are assembling a portrait of a world we cannot yet visit, using data and imagination to fill in the gaps. Proxima B remains a profound mystery, its secrets carried only by the faint light that travels across the cosmic void to reach us. Its environment is shaped by the gentle, persistent glow of its star and the tight embrace of its close orbit, forging conditions unlike any we know. Proxima B is a world utterly unlike any in our solar system, a place of endless twilight, distant hope, and cosmic wonder. Proxima Centauri is a volatile red dwarf, unleashing powerful stellar flares. Proxima B, orbiting so close, is bombarded by intense X-rays and charged particles. These flares can deliver radiation hundreds or thousands of times greater than what Earth receives. Such radiation can strip away atmospheres, break down organic molecules, and sterilize the surface. Any life would need extreme shielding, perhaps living deep underground or underwater. The planet may lack a magnetic field, leaving it exposed to the star's relentless stellar wind. Proxima B receives about 400 times the X-ray flux Earth does. The right temperature for water means little if the radiation is lethal. Proxima B's greatest challenge is surviving its own star. Proxima B is almost certainly tidally locked. One side always faces the star, the other is in eternal darkness. The day side is scorched, the night side frozen. Only a narrow terminator zone between the two extremes might offer moderate temperatures. Here, the sun would hover on the horizon, never rising or setting. Life would have to adapt to constant dim red light. The temperature difference drives powerful winds, circling the planet at hurricane speeds. The surface would be stormy and inhospitable, even in the twilight zone. Tidal locking creates a world of extremes, fire on one side, ice on the other. Survival would depend on finding balance in the narrow band between. Proxima B's atmosphere, if it exists, is under constant attack from stellar flares and wind. Over billions of years, these forces could strip the planet bare. Tidal locking would create colossal winds, making the surface harsh and turbulent. The atmosphere's composition is unknown. A thick one could trigger a runaway greenhouse effect, a thin one would offer little protection. On the night side, the atmosphere could freeze and fall as snow or ice, trapping gases away from the day side. This could leave the day side exposed to radiation, with little chance for a stable climate. Without a global, circulating atmosphere, habitability becomes unlikely. Proxima B's climate is a puzzle with many missing pieces. Proxima B is a hostile world for humans. It may have no atmosphere, or one that's toxic and unbreathable. Radiation from stellar flares would be deadly, requiring habitats deep underground. The narrow Terminator Zone is the only possible refuge, but it's plagued by violent, relentless winds. Building and surviving there would be a monumental challenge. The perpetual twilight would disrupt our natural rhythms. Water, if it exists, could be frozen or vaporized, and hard to access. Every basic need, air, water, protection, would require advanced technology. Proxima B is not a future home for humanity. It's a place to study, not to settle. Despite its hostility, Proxima B is one of the most important exoplanets ever found. Studying it teaches us about planets around red dwarfs, the most common stars in the galaxy. Future telescopes will analyze its atmosphere, searching for water, oxygen, or signs of life. Precise measurements will reveal its true mass and composition. Proxima B is our closest exoplanet laboratory, testing our theories in a real alien setting. It helps us understand what makes a planet truly habitable. Even if it's barren, that knowledge is crucial. Proxima B brings us closer to answering, are we alone? Proxima Centauri B is the planet next door, a world that sparked dreams of another Earth. Its discovery was a triumph, but a closer look reveals a harsh reality. Violent flares, lethal radiation, and tidal locking make it deeply inhospitable. The lack of a breathable atmosphere and extreme weather seal its fate. For humanity, Proxima B is not a new home, but a distant, dangerous frontier. Yet its story is one of knowledge, not disappointment. It teaches us that habitability is fragile and complex. By studying Proxima B, we learn what makes Earth so precious. It remains a prime target for astronomers, a cosmic laboratory guiding our search for a true Earth twin. Proxima B reminds us, the universe is vast, and our journey of discovery has only just begun. Look up at the night sky. Let your eyes adjust to the darkness, and you'll see a tapestry of stars stretching across the universe, each one a beacon of possibility. Each point of light is a sun, burning millions or even billions of miles away, many with planets of their own, orbiting in silent, cosmic dance. For all of human history, we've gazed at these distant worlds with wonder, curiosity, and a longing to know what lies beyond. We are explorers by nature, driven to cross oceans, climb mountains, and map the unknown. This drive took us across continents, to the moon, and into the vastness of space, and now, it leads us to a new question. Could we transform an alien planet into a second Earth, a place where life can thrive? Terraforming is the ultimate creative act, reshaping another world to be like our own, turning science fiction into reality. Imagine standing on Mars, breathing the air, feeling the warmth of a sun filtered through a blue sky. Seeing blue skies, and rivers where there was only red dust, and watching life take root in a place once thought lifeless. This vision captivates scientists and dreamers alike, inspiring new generations to imagine what's possible. It's more than science fiction. It's a challenge grounded in real science, engineering, and imagination. To build a new Earth, we must first master our own, understand what makes our planet alive, and how its delicate systems work together. What are the ingredients for life? How do we nurture them, and what secrets do they hold for us? What conditions allow water to flow, shield us from radiation, and provide air to breathe? These are questions we must answer. Terraforming pushes the boundaries of possibility, forcing us to think in centuries, even millennia, as we plan for futures we may never see. It's a project for many generations, a profound expression of our intelligence, creativity, and yearning for connection with the cosmos. Life transformed Earth from a barren rock to a vibrant oasis, shaping continents, oceans, and skies. Now, we dream of writing the next chapter of that story on another world, painting new worlds with the colors of life and hope. Earth is a paradise, a rare oasis in the vastness of space, teeming with life and vibrant ecosystems. But this is only possible because of a delicate balance of conditions that exist nowhere else, at least as far as we know. Earth sits in the habitable zone, just the right distance from the sun for liquid water to exist, which is essential for life as we understand it. Most planets, however, are not so fortunate. They orbit too close or too far from their stars, or have other conditions that make life impossible. These are worlds of extremes, scorched by heat, frozen solid, battered by storms, or shrouded in toxic clouds, utterly hostile to life as we know it. The main culprits that make a planet uninhabitable are its atmosphere, temperature, and the level of protection it offers from space hazards. Earth's atmosphere is a unique, breathable mix of gases, dense enough to provide pressure, shield us from harmful radiation, and keep temperature stable. Mars's air, by contrast, is thin and mostly carbon dioxide, unbreathable, offering little protection, and deadly to humans and most known life. Venus's atmosphere is the opposite, thick, toxic, and crushing, with clouds of sulfuric acid, and a pressure that would flatten any spacecraft. Temperature is another major barrier. Mars is frigid, averaging -60 Celsius, with nights that plunge even colder. Venus, on the other hand, is a furnace, with surface temperatures hot enough to melt lead and destroy electronics in minutes. Neither world is remotely suitable for us. For life to thrive, protection from space is crucial. Earth's magnetic field acts as a shield, protecting us from solar radiation and helping to keep our atmosphere from being stripped away. Mars lost its magnetic field long ago, leaving it vulnerable to the relentless solar wind. Now Mars is bombarded by radiation, and its thin atmosphere is constantly eroded by the sun's energy. Without a protective shield, any planet is exposed to the harshest forces in space, cosmic rays, solar flares, and more. Understanding these challenges is the first step to imagining how we might one day overcome them and transform a hostile world. To terraform a planet, we must solve the problems of air, temperature, and protection, each a massive challenge on its own. Only by addressing all three can we hope to make another world truly habitable, turning a barren rock into a new home. The odds are daunting, the obstacles immense, but the dream of reaching new worlds and making them livable persists. The next step, finding the right candidate planet, could one day change the fate of humanity. When we dream of terraforming, we imagine reshaping entire worlds, turning barren, hostile planets into places where life could thrive. The idea is as bold as it is inspiring, and it starts with looking at our closest cosmic neighbors. We look to our solar system neighbors, searching for worlds that might one day support human life. But not every planet is a good candidate. Gas giants like Jupiter and Saturn are out. There's no solid ground to stand on, just endless clouds and crushing pressure. Mercury, meanwhile, is far too close to the sun. Its surface is blasted by solar radiation and swings between extreme temperatures. That leaves two worlds that truly stand out, Mars and Venus, each with their own unique challenges and possibilities. Mars is the most studied candidate for terraforming. Scientists have sent dozens of missions to explore its surface and atmosphere. It's cold, dry, and has a thin atmosphere, but evidence shows it once had flowing rivers and vast lakes, signs of a warmer, wetter past. The goal is to restore Mars to that ancient state, reviving its climate and maybe even its lost seas. Mars's day is similar to Earth's. It has seasons, and it holds vast reserves of water ice at its poles, crucial resources for future settlers. Terraforming Mars feels almost like a restoration project, working with the planet's own history to bring it back to life. Venus, on the other hand, is a much tougher challenge, often called Earth's evil twin. Venus is similar to Earth in size and gravity, but its surface is a planetary inferno, with crushing pressure, toxic air, and searing heat that melts lead. Terraforming Venus would mean removing most of its thick carbon dioxide atmosphere, cooling it by hundreds of degrees, and somehow making it habitable, a monumental task. Unlike Mars, this isn't restoration, it's total transformation, rewriting the planet's destiny from scratch. Both worlds present unique puzzles for science and engineering, each demanding creativity and perseverance. Mars offers hope for a second Earth. Venus, a test of our most ambitious cosmic engineering dreams. The question remains, which world will humanity choose to tackle first, and what will it take to make that dream a reality? The first step in terraforming is building a new atmosphere. For Mars, that means making the air much thicker. Mars has vast reserves of frozen carbon dioxide, dry ice in its poles and soil. The key release this CO2 by heating it, thickening the atmosphere and triggering a greenhouse effect. Ideas include giant orbital mirrors focusing sunlight on the poles or factories pumping out potent greenhouse gases. As the atmosphere thickens and warms, more ice sublimates, creating a feedback loop. Increased pressure would eventually allow liquid water to exist on the surface. We couldn't breathe this new air yet, but it's the foundation for future steps. This process would take decades, even centuries. But it's the critical first domino in transforming a dead world. A thicker sky is the beginning of a new planet. Step 2. Add water. Life needs liquid water. Mars has plenty, locked away as ice. The challenge is melting it. As Mars warms, ice in the poles and underground would thaw. Water vapor would enter the atmosphere, further accelerating warming. Eventually, clouds would form, and the first Martian rain or snow in eons would fall. Water would carve new rivers and fill basins, creating lakes and seas. But risks abound: sudden floods, toxic brines from Martian soil, and uncertainty about how much water is truly accessible. The first Martian seas would be harsh and undrinkable, full of dissolved chemicals. Purifying this water would be a challenge for future engineers. Still, a working water cycle is essential for life. With air and water, Mars would be on its way to habitability. The next step, managing the climate. Atmosphere and water are just the start. A planet's temperature must be managed. For Mars, the goal is to warm it up, but not too much. The greenhouse effect from CO2 and water vapor does most of the work. We'd want to darken the surface, maybe by spreading dust from Mars's moons, to absorb more heat. Venus is the opposite. It needs dramatic cooling. Ideas include a giant sunshade in orbit, blocking sunlight and freezing out the thick CO2 atmosphere. Or, introduce hydrogen to react with CO2, creating water and graphite. These are colossal engineering feats, far beyond our current abilities. But managing a planet's thermostat is essential for long-term habitability. It's a delicate balance, too hot or too cold, and life can't thrive. Terraforming means thinking like planetary engineers. Only then can we create a stable, living world. With air, water, and warmth, a planet is ready for life, but not for humans yet. The first pioneers would be microbes, tough, engineered organisms like cyanobacteria. These microbes would photosynthesize, turning CO2 into oxygen, just as they did on early Earth. Other microbes would detoxify the soil and begin creating organic matter. This process would take centuries, slowly building up oxygen and fertile soil. Only then could we introduce hardy plants, mosses and grasses, to accelerate oxygen production. Over generations, a complex ecosystem would emerge. Each new species would prepare the way for the next. Eventually, animals and humans could follow. Life would transform the planet just as it did on Earth. Terraforming is a symphony of biology, played out over millennia. Terraforming is too vast and dangerous for humans alone. The real work will be done by machines, autonomous robots. Imagine self-replicating factories on Mars, building more factories, creating a global network of automated industry. Specialized robots would process the atmosphere, mine ice, and monitor progress. These machines must be robust, intelligent, and self-repairing. But giving control to AI brings risks, bugs, unintended consequences, and ethical dilemmas. We'd need safeguards and remote control to prevent disaster. The power to build a world comes with the responsibility to control our tools. Terraforming would change humanity forever. It's the ultimate insurance policy, a second home if disaster strikes Earth. The project would demand global cooperation and spark new technologies. But is it possible? The challenges are immense, the timescales vast, and the ethics complex. If Mars harbors native life, do we have the right to change it? For now, terraforming is a dream, a what-if that inspires us to explore and learn. Today, we send robots to Mars. Tomorrow, maybe humans. One day, our descendants might look up at a blue Martian sky and see Earth as a distant star. They'll remember where we began and how we reached for new worlds. The story of life continues, written across the cosmos. The universe is vast, stretching far beyond what our eyes can see or our minds can truly comprehend. It's filled with more stars than there are grains of sand on every beach and desert on Earth combined, a number so large it's almost impossible to imagine. For centuries we've gazed upward and wondered, are we truly alone in this cosmic ocean, or is there life elsewhere, waiting to be discovered? Is there another world out there, one that mirrors our own blue planet, with oceans, clouds, and maybe even life? This timeless curiosity has driven us to invent ever more powerful telescopes and to send robotic probes into the darkness, reaching farther than ever before in search of answers. In the 21st century, our efforts have paid off. We've discovered thousands of exoplanets, distant worlds orbiting other stars. Most are inhospitable, with scorching heat or freezing cold, but a select few, like Proxima Centauri B, ignite our imagination and hope. Proxima B is the closest exoplanet to us, orbiting a star just over 4 light-years away, a neighbor in cosmic terms. It circles the star nearest our Sun, making it a tantalizing target for exploration. Its proximity makes it a prime candidate for our interstellar dreams, fueling visions of humanity's future among the stars. The idea of transforming a barren alien world into a new Earth, terraforming, is perhaps humanity's most ambitious engineering vision. But is such a feat possible, or is it destined to remain science fiction? The hope of a second home is comforting, especially as we witness our own planet's fragility from space. As Earth faces climate change, resource depletion, and other mounting threats, the idea of a backup world becomes more urgent. This dream has fueled generations of science fiction, and inspired scientists and engineers to think beyond our immediate problems, daring to imagine what might be possible. The journey to another star is monumental, requiring technology and perseverance on a scale we've never attempted before, but the reward could be nothing less than the survival and flourishing of our species, ensuring our story continues among the stars. We now know a potentially rocky, Earth-like world exists on our cosmic doorstep, waiting to be explored. Technology lets us dream of reaching it, and every new discovery brings us a step closer. Yet the gap between dreaming and doing is immense, filled with daunting technical, financial, and ethical challenges. To see if we could ever call Proxima B home, we must confront the staggering realities and limitations of our current knowledge. We need to dissect the science of terraforming, examine the planet's unique environment, and honestly assess the colossal challenges that stand in our way, from atmosphere to radiation to resources. The question isn't just can we do it, but should we? What are the moral and philosophical implications of reshaping another world? Ultimately, this pursuit reveals as much about our hopes, fears, and ambitions as it does about the universe itself. What does it mean to terraform a planet? To terraform is to make a world Earth-like. Imagine arriving at a barren plot and transforming it into a lush garden on a planetary scale. Terraforming means changing a planet's atmosphere, temperature, and ecology to resemble Earth's. The first step, create a breathable atmosphere with the right mix of nitrogen and oxygen. The atmosphere must be thick enough to protect from radiation and allow liquid water. Next, adjust the planet's temperature, warming a cold world or cooling a hot one. The goal, a stable, moderate climate where water can exist. Finally, introduce life, starting with hardy microorganisms to process the atmosphere and enrich the soil. Over centuries, more complex life could follow. Plants, insects, animals. Terraforming is not a quick fix. It's a project spanning generations. It's the ultimate act of planetary creation. But is it within our reach? To understand terraforming Proxima B, we must first know where it is in the vastness of space and why it captures our imagination. Proxima B orbits Proxima Centauri, our Sun's closest stellar neighbor, just over 4 light-years away, a distance that, in cosmic terms, makes it our next-door neighbor. Even so, it's unimaginably distant. Our fastest spacecraft would take tens of thousands of years to get there, making any journey a monumental challenge for humanity. Proxima Centauri is a red dwarf, much smaller and dimmer than our Sun, glowing with a faint reddish light that barely illuminates its surroundings. Proxima B orbits extremely close to its star, nestled within the habitable zone where, in theory, liquid water could exist on its surface. This discovery was monumental, a rocky planet, slightly more massive than Earth, in the right zone for life as we know it, sparking hope for finding another world like our own. That's why Proxima B excites scientists everywhere. It's the most accessible, potentially habitable exoplanet we know, and a prime candidate in the search for life beyond Earth. But orbiting a red dwarf so closely brings dangers that are very different from those on Earth. Red dwarfs unleash powerful flares, bombarding nearby planets with intense radiation and energetic particles that could strip away atmospheres. Proxima B likely faces radiation levels far beyond Earth's, making its surface a harsh and potentially hostile environment for life. It's probably tidally locked, one side in perpetual day, the other in endless night, creating a world of extremes. This creates extreme temperature differences, with one hemisphere scorched by constant sunlight and the other plunged into freezing darkness. The day side could be unbearably hot, while the night side remains frozen and inhospitable. Ferocious winds would sweep between the two, as the planet's atmosphere tries to balance these extremes, creating violent weather patterns. Proxima B is both tantalizing and deeply challenging, a world that tempts us with possibility, yet warns us of its dangers. Can we overcome these obstacles and one day call Proxima B a second home for humanity? Terraforming Proxima B would begin with robots, not humans. Fleets of autonomous probes would survey the planet, its composition, atmosphere, water, and magnetic field. If promising, we'd need to build an atmosphere, perhaps by redirecting comets rich in water and gases to crash into the planet. This cometary bombardment would take centuries, slowly building up atmospheric pressure. We'd also need to manage temperature, sunshades to cool the day side, mirrors to warm the night. The twilight zone between day and night might be the most habitable. With a basic atmosphere and stable temperatures, we'd introduce engineered microbes to process the air and soil. These organisms would slowly create a self-sustaining ecosystem. This biological phase would take thousands of years before plants, animals, or humans could arrive. Terraforming is a marathon, not a sprint. The greatest obstacle isn't technology, it's distance. Proxima Centauri is over 4 light-years away. Even light takes years to get there. Our fastest probes would need 75,000 years to make the trip. To send machines and materials, we'd need revolutionary propulsion, fusion rockets, or laser-driven light sails. Light sails could send tiny probes in decades, but not the massive payloads needed for terraforming. A world ship, an interstellar ark, might carry people and equipment, but the journey would span generations. The logistics are staggering: closed-loop life support, shielding from cosmic rays, and enough resources to start a civilization. The psychological and social challenges of a multi-generational voyage are immense. The tyranny of distance makes the journey as daunting as terraforming itself. Reaching Proxima B is a challenge for future civilizations. Are we ready for such a leap? Even if we could reach Proxima B, we'd find a world hostile to life. Radiation from frequent stellar flares would sterilize the surface without a strong magnetic field and thick atmosphere. Tidal locking means one side is scorched, the other frozen, with violent winds in between. We don't know if Proxima B is a dry rock or an ocean world. Each presents unique challenges. If it's dry, we'd need to import vast amounts of water. If it's oceanic, there may be no land to build on. The star's dim, red light would make photosynthesis difficult for Earth plants. We'd need to engineer new life forms or rely on artificial lighting for food. Every aspect of Proxima B is alien and unforgiving. Creating a breathable atmosphere on Proxima B would be a colossal task, one that pushes the limits of our imagination and technology. If the planet is bare, we'd need to release trapped gases by heating rocks or crashing asteroids, an energy-intensive process that would require vast resources and advanced engineering. The initial atmosphere would likely be carbon dioxide, making the planet uninhabitable for humans at first. To truly make Proxima B livable, we'd need to add both nitrogen and oxygen in the right proportions. Nitrogen could come from redirecting ammonia-rich asteroids, which would need to be carefully guided to avoid catastrophe. Oxygen might be produced by splitting water molecules through electrolysis, a process that itself demands a reliable energy source and abundant water. The most elegant solution could be engineered microbes, like cyanobacteria, designed to convert CO2 into oxygen, essentially jump-starting a new biosphere from scratch. This process would take millennia, even with advanced technology, as the planet's environment slowly transforms over countless generations. But there's a catch: Without a magnetic field, the atmosphere could be stripped away by relentless stellar winds, undoing centuries of work. We don't yet know if Proxima B has this crucial protection, or if we'd need to invent a solution ourselves. Creating an artificial magnetic field for an entire planet is far beyond our current abilities, and would be a technological leap of unprecedented scale. Without it, any atmosphere we create could slowly leak into space, making all our efforts temporary at best. Terraforming Proxima B means fighting both time and physics. The challenge is immense, so is it even possible or just a dream for future generations? Terraforming another world would dwarf any project in human history. The cost isn't just in money, but in the total energy and resources of our civilization for centuries. Powering factories, redirecting asteroids, and generating a magnetic field would require energy sources far beyond our current capacity. Should we invest so much in a distant dream when Earth faces urgent problems? The project would need sustained commitment for centuries, something humanity has never achieved. Civilizations rise and fall, priorities change. A single global crisis could end the project, leaving a half-finished world light years away. The true cost is not just financial, but a test of our focus and unity over millennia. Is terraforming Proxima B a dream or a delusion? With today's technology, it's a fantasy. Distance, radiation, and planetary unknowns are nearly insurmountable. We struggle to manage Earth's climate, let alone engineer a new biosphere light years away. Each step, building an atmosphere, generating a magnetic field, seeding life, is a challenge beyond anything we've done. Yet, great dreams drive progress. The dream of flight led to airplanes. The dream of the moon led to Apollo. Dreaming of Proxima B pushes science and imagination forward. For now, it's a dream deferred, a goal for a far future humanity. The real value lies in the questions it inspires and the innovations it sparks. Proxima B remains a beautiful, humbling dream, one that reminds us to cherish and protect our own world.